Hello everyone. In this class, we'll learn about electroencephalogram, that is EEG, and sleep. The learning objectives would be to understand the functional organization of the cortical and subcortical neurons in the genesis of EEG, name the EEG waves and their mechanism of genesis, name the stages of sleep and draw EEG waves in different stages, and understand the mechanism of NREM and REM sleep. List the differences between NREM and REM sleep. Understand the theories of sleep and understand the physiological basis of sleep disorders. Electroencephalogram. EEG is the record of spontaneous electrical activity generated in the cerebral cortex and are picked up from the brain surface through electrodes placed on the designated site on the scalp. These electrical activities reflect the electrical currents that flow in the extracellular spaces in the brain. These electrical currents reflect the summated effects of innumerable excitatory and inhibitory synaptic potential upon the cortical neurons. These spontaneous activities of cortical neurons are greatly influenced by afferent inputs arising from thalamus and brainstem reticular formation. These afferent impulses enter the cortical neurons to produce most of the characteristic rhythmic EEG waves. Electroencephalography is the procedure of recording EEG. Electroencephalograph is the sensitive device that records EEG. EEG is the best diagnostic tool available for assessing the abnormalities of electrical activities of the brain. Therefore, EEG is very helpful in diagnosing epilepsies and for studying sleep and sleep disorders. Procedure of recording. Hans Berger, a German psychiatrist in 1929, for the first time demonstrated that the electrical activities of human brain could be recorded using external electrodes on the scalp, which he termed as electroencephalogram. As the EEG waves are of very low voltage, they require more amplification before recording. EEG leads may be bipolar, that is comparing the potential between two active leads, or it can be unipolar, that is measuring the potential changes at the single lead against the reference lead, which is placed on the ear or nose or on chin. The EEG electrodes are solder or silver chloride disc of 0.5 centimeter diameter. Recording is done with the subject preferably in recumbent position and his head and neck supported to ensure that the posterior electrodes are secure. Usually 4 leads are attached to the scalp by means of adhesive material on the standard skull locations on each side. A multi-channel pen recorder is used to record the activities from the 8 leads simultaneously. The EEG waves are analyzed manually or by using computer. Different EEG waves. EEG waves are described in terms of their frequency, which is usually ranges from 1 to 30 Hz, and amplitude, which ranges from 20 to 100 microvolts. Characteristic of EEG wave vary according to the state of consciousness. When the individual is fully alert, that is, sensory inputs are maximum, the waves are mostly of high frequency and low amplitude with as many units asynchronized. When the person is minimally alert, as in deep sleep, the least sensory input, waves are of low frequency and high amplitude and they are synchronized. Absence of EEG waves indicates brain death. EEG wave patterns are classified into 4 types, that is alpha, beta, theta, and delta according to their frequency. The characteristic feature of various EEG rhythms are as follows. The alpha rhythm frequency ranges from 8 to 13 Hz and amplitude from 50 to 100 microvolts. This is the most prominent EEG rhythm seen in a normal adult at rest. Adult at rest means awake but relaxed with the eyes closed. It is found in the posterior half of the brain, especially in the parieto-occipital regions. Alpha rhythm disappears upon opening of the eyes or the subject engaging in mental efforts such as mental arithmetic. The regular alpha rhythm is replaced by irregular low voltage activity, and this phenomenon is called as alpha block or desynchronization. This is also called as arousal or alerting response. Factors affecting alpha wave frequency. The frequency of alpha wave is decreased by hypoglycemia, hypothermia, high arterial pressure, and low levels of glucocorticoids. High blood glucose, increased body temperature, low arterial pressure, and high levels of glucocorticoids increase frequency of alpha rhythm. Coming to beta rhythm, frequency of beta waves ranges from 13 to 30 Hz with a low amplitude ranging from 5 to 10 microvolts. This is seen in adults where eyes are open. These waves appear in posterior regions. Beta rhythms are sometimes seen in frontal regions regardless of whether the eyes are closed or open. The theta rhythm, frequency of theta wave ranges from 4 to 8 Hz with a large amplitude. Usually the theta rhythm is seen in normal children. It also occurs during moderate sleep. It may sometimes appear in adults when they are severely disappointed or depressed. Delta rhythm. Frequency of delta waves ranges from 0.5 to 4 Hz and amplitude from 20 to 200 microvolts. Delta rhythm occurs normally during deep sleep. Its appearance in an alert state in adults suggests serious organic brain damage. So these are the normal adult brain waves. So when the awake and resting, you will be able to see the alpha rhythm with 8 to 13 hertz, and when you are awake with the mental activity, they are converted into uh, beta rhythm with a frequency of 4 to 30 hertz, okay, so which is called as alpha block. Okay, and while sleeping and deep sleep, you will be able to see the theta waves, so which is having the lower frequency and higher amplitude, and delta much higher amplitude and lower frequency. EEG rhythms in infants and children. The EEG recording in children show wide range of patterns. Usually in awakened infants there is fast beta rhythm. The rhythm speeds up during childhood and theta rhythm appears. As the child matures, the theta rhythm is replaced by faster alpha rhythms. The alpha rhythm of adults gradually disappear during adolescence. The theta rhythm is prominent in the temporal or parietal region, while the alpha rhythm is the prominent in the occipital region. Neural basis of EEG. EEG is summated synaptic potential that are generated in the activated pyramidal cells. This is because of the typical arrangement of the pyramidal cells. Pyramidal cells are oriented parallel to one another, and their dendrites are oriented perpendicular to the surface of the cortex. Synaptic activity at any point along dendrite may be depolarizing or hyperpolarizing. The local potential change creates the difference between the active site, so which is called as a sink, and the remainder of the dendritic shaft, which serves as a passive current source. The potential difference between the sink and the source is similar to that of an electrical dipole, and it is proposed that the flow of current between them is responsible for the EEG wave. Sleep and EEG. Sleep is defined as a temporary state of unconsciousness, more accurately, withdrawal of conscious from the physical world, from which the subject can be aroused with appropriate sensory stimulus. Though about one third of our life is spent in sleep, the time spent in sleep is not wasted, as sleep is essential for normal growth and the development of mind and body. An individual is kept awake by activation of reticular activating system. Sleep occurs due to the periodic shutdown of reticular activating system by influences from brainstem and other regions of brain. Arensky, Dement, and Kleitman in 1953, through EEG and polygraphic analysis, described that normal sleep consists of recurring cycles of different stages, each of which characterized by specific EEG changes associated with autonomic and endocrine changes. They discovered that some particular stages in sleep are accompanied by rapid eye movements, so which are usually called as rapid eye movements, which do occur in other stages, which do not occur in other stages other than REM. Accordingly, the sleep was divided into two phases, the REM sleep and non REM sleep. The non REM sleep is known as slow wave sleep, and whereas REM sleep is known as a paradoxical sleep. So, again, these are the different uh, waves at the different stages of sleep. Okay, so, when awake, you can see the beta rhythm, and these are the sleep waves which you will be able to see in the different stages of sleep, that is stage 1, stage 2, stage 3, and stage 4. Stage as the the sleep deepens, the amplitude of the EEG is going to increase and the frequency is going to reduce. And in stage 2, you can see typically the sleep spindles or the K complexes. Sleep cycles. The EEG pattern recorded during sleep varies in a cyclic fashion, which repeats in about every 90 minutes. Thus, there are about 4 cycles in a normal 6 to 7 hours of sleep. In normal individuals, sleep cycle begins with slow wave sleep or non-REM sleep. So there are 4 stages of slow wave sleep, that is stage 1 to stage 4. A person when falls asleep passes sequentially through these 4 stages and increasingly of deep sleep. After that, sleep lightens and he enters into the REM period. With the completion of REM phase, the sleep cycle completes. The REM phase is followed by the next new cycle, that is with the stage 1 to non REM sleep. Thus, the cycle repeats in every 70 to 90 minutes. There are differences in the proportion of the time spent in various sleep stages in different age groups. Moreover, each individual has his or her own characteristic pattern. Usually, there is a predominance of deep slow wave during the early part of the night, and the first REM sleep may occur after an hour. But REM stage becomes prevalent during the later part of the night. In general, IM sleep occupies about 25% of the total sleep period. Slow wave sleep. As the individual goes to sleep, he advances from stage 1 to stage 4 of the slow wave sleep. There are 4 stages of progressively deepening sleep. It is difficult to wake up the subject in the slow wave sleep, during which the EEG pattern becomes progressively slower and the frequency uh, and higher in amplitude. That is, the frequency is going to reduce and the amplitude is going to increase. Stage 1, where subject becomes drowsy, the EEG shows change from beta to alpha rhythm. Immediately, the light sleep begins, during which the alpha rhythm is replaced by high frequency and low amplitude EEG waves. Stage 2, the subject enters the amplitude of ECG waves slightly increases in this stage. The hallmark of EEG in this stage 2 are the sleep spindles and K complexes. Sleep spindles are the burst of alpha like activities having a frequency of 12 to 14 hertz and amplitude around 50 microvolts, which lasting for about 2 seconds. They are called sleep spindles because their characteristics their characteristic of waxing and waning type of amplitude. K complexes are the high amplitude sharp waves appearing irregularly in the EEG. They're also characteristic of stage 2. Stage 3, in this stage, the moderately it's a deep sleep. The rhythm of the EEG waves shows lower frequency and higher amplitude. Stage 4 is a stage of deep sleep with a delta rhythm predominant over the whole scale. Maximum slowing with large amplitude waves is seen in this phase. So it is very difficult to wake up the subject in this stage. In the young adults, maximum time of sleep spent in stage 4. Okay, so this is showing the different uh, the sleep cycles. Okay, so when he awakes and falls into the sleep, so initially they will pass with the different stages. The sleep is going to deepen from stage 1 to stage 2, stage 3, and stage 4. Okay, so then the sleep is going to lighten in the next uh, few minutes. So then it is going to go to the stage 3, stage 4. Then he comes back to the REM sleep. Okay, he is going to spend some time in REM sleep. So then the deep sleep appears. Again he goes for the next cycle is going to uh, onset with stage 1, stage 2, stage 3, and stage 4. Then the sleep lightens again to go into the REM sleep. So that is how the sleep cycle is going to continue. The autonomic and other changes during slow wave sleep. So there can be decrease in the heart rate and blood pressure. There will be fall in the body temperature. The respiration becomes slow and regular. There will be increased intestinal gastrointestinal activity, which indicates that there is increased parasympathetic activity. There will be decreased muscle tone. So there will be no rapid eye movements in NREM's phase. Sleep is deep in stage 3 and stage 4. Control mechanisms of slow wave sleep. The mechanisms controlling slow wave sleep may be broadly divided into neural and chemical mechanisms. The neural control mechanisms of slow wave sleep may be subdivided into three categories, that is, afferent control, central control, and circadian control. Afferent control, it is known that the repeated and monotonous stimulation of mechanoreceptor or afferents from these receptors at frequency less than 10 Hz produces sleep. This is mediated by low frequency stimulation of brainstem and other areas that activates the sleep producing areas in the brain. The central control, where there are three brain areas that on appropriate stimulation produce slow wave sleep. These sleep zones are diencephalic zone, medullary zone, and basal forebrain zone. The diencephalic zone, this zone is formed by posterior hypothalamus and interlaminar and anterior thalamic nuclei close to the hypothalamus. Low frequency stimulation of this zone produces EEG pattern that resembles slow wave sleep. The medullary zone, the reticular formation at the level of nucleus tractus solitarius in medulla constitutes the medullary sleep zone. Low frequency stimulation of this zone produces slow wave sleep. Then basal forebrain zone, that is a preoptic area of the hypothalamus and diagonal band of Broca forms this zone where the stimulation either high or low frequency produces slow wave sleep. Then circadian control. It was observed in experimental animals that the destruction of the suprachiasmatic nucleus disrupts many behavioral and circadian rhythm, including sleep-wake cycle. The suprachiasmatic nucleus is the biological clock which is influenced by light dark cycles through the retinohypothalamic pathway. Thus, day night variation controls sleep by influencing inherent rhythmic discharge of biological clock. Then chemical control mechanisms for the slow sleep, the that means deep sleep. The center for mechanism governing the NREM and REM sleep lies in the pons, which is influenced by serotonin, norepinephrine, acetylcholine, adenosine, and prostaglandins. Serotonin is clearly known as the uh, it is clearly known that serotonin agonist suppresses sleeps and serotonin antagonists induce slow sleep in particular. Serotonergic projection from the rafin nucleus to thalamus and cortex plays a role in the control of sleep. Then the chemical norepinephrine. Cells in the locus coeruleus release norepinephrine. Fibers from locus coeruleus project to the spinal cord and also to the cortex. The ascending fibers on stimulation prevent sleep and descending fibers inhibit motor neurons that produce hypotonia during slow wave sleep. Administration of L-DOPA, that is a catecholamine precursor, causes increase in wakefulness. Stimulation of the adrenergic fibers of the reticular formation leads to EEG arousal and spinal facilitation. Inhibition of catecholamine synthesis leads to decrease in EEG arousal, that is, uh, move towards EEG synchronization. Considerable evidences suggest that decrease in brain monoamine causes increase in REM sleep and vice versa. Acetylcholine, where cholinergic neurons projecting rostrally from the dorsal pontine tegmentum, are part of the RAS. Acetylcholine secreted from these neurons play a role in control of sleep. It is proposed that cholinergic mechanisms selectively promote REM sleep. Adenosine induces sleep, whereas caffeine, which is antagonist of adenosine, is known to produce alertness. Prostaglandin, uh, that increased prostaglandin concentration, that is PGD2, in the medial preoptic area induces sleep, and increased concentration of PGE2 decreases slow wave sleep and produces wakefulness. Into paradoxical sleep, that is REM sleep. After completion of slow wave sleep, a new pattern of EEG waves starts suddenly. During this stage, slow waves are replaced by rapid low voltage EEG frequency. This is called as paradoxical sleep. Because the EEG activity is very rapid, like beta rhythm, as seen in awakened state. Still, it is difficult to awaken the individual. In fact, threshold for arousal by sensory stimuli is raised during this stage. So this phase lasts for about 10 to 15 minutes. Features of paradoxical sleep, that is REM sleep. Paradoxical sleep is characterized by rapid and roving eye movements, even visible under closed eyelids. Therefore, paradoxical sleep is also called as rapid eye movement sleep. The EEG pattern shows desynchronized high frequency and low voltage like fast beta rhythm. Yet it is difficult to arouse the individual from sleep as the threshold for sensory stimuli is raised. However, the subject is likely to awake spontaneously from REM sleep than any other stage. Another characteristic feature of REM sleep is the appearance of PGO spikes in EEG. The PGO spikes are phasic potential that occur in groups of 3 or 5. They originate in pons and through lateral geniculate body travel to the occipital cortex. Therefore, they are called as pontogeniculo-occipital spikes or PGO spikes. If the subject is awakened from REM sleep, he commonly reports that he was dreaming. The dream is easily remembered in this stage, but usually it is not of frightful type, which occurs in slow wave sleep. The REM sleep is customarily considered as a dream sleep. There will be sympathetic uh, system stimulated, the heart rate and the blood pressure are increased, and respiration is rapid and sometimes may be irregular. In males, penile erection occurs. This is used in diagnosing impotence, in which erection does not occur in REM sleep. The muscle tone is profoundly depressed. Hypotonia is widespread. However, there are two exceptions. The two group of skeletal muscles not involved in hypotonia are extraocular muscles, which causes the rapid eye movements, and the muscles of middle ear ossicles, so that protect the inner ear. Hypotonia occurs due to the active inhibition of motor neurons by a group of neurons located close to the locus ceruleus in the brainstem. The stretch reflexes are inhibited. The mechanism of paradoxical sleep. It can be a neural mechanism. The EEG pattern of REM sleep resembles EEG recording during the alerting response. From the PET scanning in humans, it is observed that the neuronal activity increases in pons, amygdala, and cingulate gyrus during REM sleep. The mechanisms that generate REM sleep are located in the pontine reticular formation. Rapid eye movements, the hallmark of REM sleep, are triggered by the potential originating from the pons and in the form of PGO spikes. The chemicals which are responsible for REM sleep. Acetylcholine seems to mediate REM sleep. In cat, administration of atropine suppresses paradoxical sleep, whereas injection of physostigmine, which promotes acetylcholine activity, increases the duration of REM sleep. It is also seen that decrease in brain monoamine causes increase in REM sleep. Reserpine, a drug that depletes monoamine stores, blocks slow wave sleep and hypotonia and EEG desynchronization seen in REM sleep. However, the reserpine enhances the rapid eye movements by facilitating PGO activity. Thus, the role of monoamines in paradoxical sleep appears to be a complex one. Barbiturates, they are going to decrease the duration of RAP sleep. Effect of age on sleep. The duration of REM sleep and stage 4 sleep decreases gradually with the advancing age. Newborns and infants sleep up to 18 to 20 hours a day, of which 50% is spent in REM sleep. Coming to the functions of sleep, Popper and Eccles concluded that sleep is a natural, repeated unconsciousness that we do not even know the reason for. However, sleep is essential for normal functioning of the body for the following reasons. That is, and sleep deprivation results in many dysfunctions. Sleep restores strength, both physical and mental. It improves the ability to think and concentrate in and the concentration is enhanced with adequate sleep. Sleep consolidates learning and memory. Adequate sleep promotes growth as during the sleep growth hormone secretion is more. Dreams are produced during sleep. However, utility of the dreams depends on the ability to remember and interpret them. These are some of the difference between the REM sleep and NREM and REM sleep as we discussed. The NREM sleep occurs first, then the REM sleep. The duration is 25% of the total sleep, where it is 25% REM sleep. Autonomic functions, there will be sympathetic inhibitions, that is low heart rate, blood pressure, respiration. The opposite happens in REM sleep. In NREM sleep, there is no eye movement. You can see rapid eye movement in REM sleep. Dreams are not memorized in NREM, whereas dreams are very well memorized in REM. The muscle tone is inhibited in NREM sleep, where it is profoundly depressed in REM sleep. And the type of sleep is predominantly deep sleep, and with REM, sleep lightens. You can see stage very slow wave and high amplitude EEG waves, whereas in REM we can see high frequency and low voltage brain waves. NREM sleep occurs because mainly the inhibition of RAS, that is reticular activating system, and REM sleep occurs because of the activation of pontine reticular formation. Theories of sleep, sleep wake cycle. Sleeping or remaining awake is due to the alteration between the state of sleep and state of awakeness of the sleep wake cycle. It's a rhythmical cyclical alteration in very unique phenomenon of living worlds in both animals and humans. It is also believed that even plants sleep. The exact mechanism of induction of sleep or to arouse them from sleep is not known, though many theories have been forwarded to explain the shift from one state to the other between wakefulness and sleep. Nothing is fully conclusive. However, one fact is established that sleep-wake cycle is entrained within the diurnal rhythm, which means the sleep wakefulness is synchronized to the day and night variation in the environment. The circadian rhythm plays an important role in the shift between sleep and sleep wake cycles, at least in human beings. Following theories have been proposed to explain the sleep wake cycle, that is, the role of circadian rhythm, role of pineal gland, thalamocortical loop, and alteration in neurochemicals. Many mammalian functions and behaviors are linked to circadian rhythm. The center of circadian rhythm is suprachiasmatic nucleus of hypothalamus. SCN is named for its location bilaterally above the optic chiasm. For its major influence on physiological alteration in the diurnal rhythm, SCN is designated as the biological clock. Experimental findings suggest that the peaks of circadian activity of suprachiasmatic nucleus correlate with the light-dark cycle. It has been observed that sleep-wake cycle depends on the time of exposure to the bright light. If individual is exposed to the bright light during the day, sleep-wake cycle is usually not affected. If exposed to uh, bright light after the evening, the onset of sleep is delayed. And if exposed to the early morning, that is before dawn, the onset of next sleep period is accelerated. Therefore, it was suggested that the exposure to light is an important determinant of a sleep-wake cycle. The retinal stimulation, uh, the day stimulates the retinohypothalamic pathway that activates the SCN, which keeps the individual awake by activation of reticular activating system. Cessation of retinohypothalamic activation with the onset of night, that is loss of photopic stimulation, induces the onset of sleep. It has been proposed that the SCN initiates the neurohormonal signals that entrain the circadian rhythm of sleep-awake cycle. This photic stimulation theory of retinohypothalamic pathway may be true for human beings, as many animals like a rat sleep mostly during day and remains awake mostly in the night. Role of pineal gland. Earlier, it was thought that the pineal gland is a small vestigial organ in the brain like that of vermiform appendix and GI tract. Recent evidences suggest that pineal plays an important role in the hypothalamic control of hormonal secretion and regulation of circadian rhythm. It has been observed that the activity of sympathetic fibers to pineal gland is entrained with a light dark cycle of the environment via retinohypothalamic connections of somnolescent motor starts. It may involve one or both the legs or trunks, but less often the arms. But less often the arms. It is associated with a frightening dreams or sensory experience. They are different. Uh, they are different from epilepsy in sleep or nocturnal myoclonus. Sensory paroxysms. Sensory experiences occur in paroxysm in sleep are due to the excitation of sensory centers. Patient usually gets up in sleep with the feeling that the sensation is transmitted through the body. Sudden flash or light or crashing sound or sensation of burning or lifting of the body are experienced. Abnormality usually involves labyrinthine vestibular mechanism. Nocturnal paroxysmal dystonia, characterized by choreoathetotic or ballistic dystonic movements that occur in NREM sleep in paroxysm. Patient appears awake with a fearful or astonished expression like night terrors. It may it, it affect at any age in both sexes and usually non-familiar. Sleep paralysis. Sleep paralysis occurs usually during transition from sleeping to the waking state. During this phase, patient is unable to activate their muscles. It occurs towards the end of REM sleep. Respiratory and diaphragmatic functions and eye movements are usually not affected. Night terrors and nightmares. Night terrors, which is also called as pavor nocturus, and nightmares are usually the problems of childhood. Usually this occurs after falling asleep in stage 3 or 4 of NREM sleep. Child awakens abruptly in a state of intense fright with marked tachycardia and tachypnea, and then he sleeps automatically. The episode occurs only for 1 to 2 minutes and child does not remember anything in the morning. Somnambulism is the condition in which the sleeping individual is able to stand and walk about. This is called as sleepwalk, which is just opposite of cataplexy. Usually patient sits up at the edge of the bed. Sometimes he gets down from the bed and really walks with eyes open. He may even perform some familial act without outshow of emotion, without outward show of emotion. Usually, it is seen in children and is benign, but in adults, it may be an aggressive motor act. During the act, they do not respond to external stimuli. It occurs in stage 4 of slow wave sleep, in the first third part of the sleep when usually dream does not occur. Next morning, patient does not recall anything. REM sleep behavior disorder. The parasomnic disorder occurs more commonly in adults or older men, characterized by vigorous and often dangerous motor activity that accompanies vivid dreams. They do not have history of childhood sleepwalking. Characteristically, they become aggressive, angry, and shout loudly, even become violent and cause injury to themselves or to the bedmate. The violent episodes occur during REM phase, during which hypotonia fails to occur. Coming to obstructive sleep apnea. Obstructive sleep apnea is a common disorder of middle-aged people, uh, in which time spent in stage 1 is more. Normally, the duration of stage 1 REM sleep is about 10% of the total duration of night sleep. In obstructive sleep apnea, the duration increases to 30 to 50%, and there is a marked reduction in stage 3 and stage 4 of NREM. There is a reduction in the muscular tone and respiratory drive at the onset of sleep that causes obstruction of the airway, especially of the pharynx, and that occurs because of the decreased tone of the pharyngeal muscles. Apnea occurs for more than 10 seconds during frequent episodes of obstruction. Apnea causes brief arousal from sleep that reestablishes the airway tone. But airway obstruction is repeated often throughout the night, and that decreases the duration of sleep, and the sleep is usually disturbed. Therefore, the subject feels often sleepy during daytime. Hypersomnia, that is excessive sleep. Patient sleeps for days to weeks continuously. It is usually occurs due to the damage to the brainstem reticular activating system or to the neurons in the subthalamus or hypothalamus. Recently, it has been suggested that destruction of dopaminergic neurons in the substantia nigra, resulting the overactivity of serotonergic neurons of raphe nucleus, causes hypersomnia. So this is different from the sleeping sickness that occurs in trypanosomiasis. So this is in brief about the electroencephalogram. There, the different waves that we see, the different uses, and also regarding the briefly about the sleep. Thank you.